Hello and welcome to Crisp Concepts, where complex ideas become clear and simple.
All right, welcome. You ever stop and wonder how your phone or your smart speaker or even that chatbot you were just messing with, how it actually understands what you're saying? Well, today we're going to pull back the curtain and take a look at the secret recipe that teaches machines our language. So, the core challenge is, well, it's right here. Human language is messy, it's weird, it's wonderful, it's packed with inside jokes and feelings. But computers, they think in pure, rigid logic. So the big question is, how in the world do you get those two to meet in the middle? Well, it's all thanks to this amazing field of AI called natural language processing, or NLP for short. And you can kind of think of it as the science, or maybe even the art, of teaching computers how to speak human. Okay, section 1, AI learns to talk. And the big challenge here is logic versus linguistics. We're trying to bridge two completely different worlds. Think about it like this. On one side, you've got computer language. It's super strict, it's logical, it follows exact rules. It's all just ones and zeros. But then you have human language. It's flexible, it's all about context, and it's jam-packed with slang, sarcasm, and emotion. It's kind of like comparing a perfect architectural blueprint to a wild, free-form jazz solo. So the real question is, how do we get a machine to understand not just what we say, but what we actually mean? See, the trick isn't just about recognizing words on a page. It's about getting the intent, the context. And to do that, well, the AI needs a recipe. Which brings us to our next section, the language recipe. These are the core ingredients for understanding. So yeah, think of NLP as the secret chef's recipe. It takes our raw, messy language and cooks it up into something a computer can actually understand. And this whole process, they call it the NLP pipeline. It's basically a 4-step recipe. First, you've got tokenization. That's like chopping the ingredients. Then, part of speech tagging, which is sorting them. Third is lemmatization, finding that root flavor. And finally, dependency parsing. You gotta follow the grammar rules. Let's break them down. Okay, first up, tokenization. This is the very first step. The AI basically acts like a chef chopping up vegetables. It takes a whole sentence and just slices it into smaller chunks, like individual words or phrases. And each one of those little pieces, that's called a token. Pretty straightforward, right? Next, after everything's chopped up, it's time to sort the ingredients. This is called part of speech tagging. The AI goes through each token and slaps a label on it. Okay, this one's a noun, that's a verb. Oh, here's an adjective. This gives it crucial grammatical context. It's like knowing which ingredients are your spices and which one is the main protein. All right, step 3 is all about getting to the root flavor. This is a cool one. It's called lemmatization. Here, words are reduced to their basic dictionary form. So words like running, ran, and runs all get boiled down to their core concept, which is just run. This really helps the AI understand that these are all just different flavors of the same basic ingredient. And finally, the last step is dependency parsing. This is like the AI actually reading the recipe instructions. It analyzes the grammatical structure to figure out how all the words relate to each other. It's trying to build a map of the sentence to see, who did what to whom. Now it finally understands the structure. Okay, but here's the thing. Understanding the grammar is really only half the battle. This brings us to understanding the meaning. Because it's not just what you say, it's how you say it. You can follow a recipe perfectly and still make a bland dish, right? Now we have to get to the actual meaning. And this brings us to a really key distinction, syntax versus semantics. So syntax is the grammar. It's the rules for arranging words so that a sentence is structured correctly. But semantics, that's the meaning. It's what the sentence is actually trying to say. It's the soul of the message. Yeah, as the quote says, syntax tells a computer how to arrange words, but semantics is what's going to humanize chatbots. Think about it. You can have a sentence with perfect grammar that is complete nonsense. Semantics is what lets an AI get all those subtle meanings and, not sound like a robot just spitting out words. So where do we actually see this in our daily lives? Let's talk about the amazing dishes this recipe creates. You might be surprised. The answer is pretty much everywhere. And a lot of the time, we don't even notice it's happening. I mean, just think about it. The smart assistants we all use, like Siri and Alexa, that's NLP. Those chatbots that pop up for customer service, NLP. Even the autocomplete on your phone that predicts your next word. And what about language translation, like Google Translate? or your email spam filter, or even how social media sites analyze sentiment, or banks detect fraud. Yep, all of that is NLP working behind the scenes. And this field is moving incredibly fast. Get this number, 2029. That's the year that Ray Kurzweil, who's the director of engineering at Google, predicts that AI will actually achieve human-level intelligence. I mean, just let that sink in for a second. That's not very far away. But it's not perfect, not by a long shot, which brings us to our next section, lost in translation, or as I like to call it, the kitchen nightmares of NLP. Because like any chef, AI can really mess things up. Human language is just so tricky. Okay, take a sentence like this one. I will be merry when I marry Mary. For us, that's easy. We hear the different words, we know what they mean. But for a computer, distinguishing between marry, marry, and marry, words that sound almost exactly the same but mean totally different things, that requires a deep understanding of context that an AI just might not have. And this really highlights two of the biggest challenges. First, there's ambiguity. If you say the word bat, are you talking about the animal or the piece of sports equipment? The AI has to figure that out. Then there's the challenge of context. Look at this sentence. The chicken is ready to eat. So, is the chicken about to eat some feed, or are we about to eat the chicken for dinner? A computer just doesn't have our real-world knowledge to know the difference. And the list of challenges goes on. Think about sarcasm and tone of voice. How do you teach a computer that, oh great, could actually mean this is terrible? Or what about new slang that pops up every week? AI has to constantly learn. It also struggles with handling multiple languages. And maybe the biggest one, it needs huge, and I mean huge, amounts of high-quality data just to get good at this stuff. So, what's next on the menu for the future? Well, researchers are working on some pretty amazing things. They're trying to build what's called explainable AI, an AI that can tell you why it made a certain decision. They're also working on multimodal NLP, which can understand text, images, and speech all together. And then there are cross-lingual models that can work seamlessly across different languages. This is the future. So when you step back and look at all this, it's clear this technology is changing everything about how we interact with machines. The big takeaway here is that we're not just building simple tools anymore. We're actually teaching them to speak our language, to understand us. And that leaves us with one last kind of mind-bending question to chew on. If AI truly masters language, what will it say next?